Hello everybody, welcome back. We will be looking at the mean and variance of a variable. We'll be looking for the rules for means and variables, and I'll also look at a version of the law of larger numbers. So let's say that I have a discrete random variable x, and the table here gives us the probability mass function for this variable. That is, so here p1, so x1, x2 up to xk, these are the values of the variable x, and p1 is the probability that capital X is equal to x1, p2 is the probability that x is equal to x2, and so on. So this is the probability mass function. You can also call that the distribution of x, and the mean of x is found by multiplying each value of x by its probability and then adding the products. That is, the mean of x is equal to x1 times p1 plus x2 times p2 plus dot 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 plus xk times pk. In short, we write this sum using the summation notation. So it's the summation of xi times pi, where the sum goes over all values of I from 1 to n, or 1 to k. So so recall that let's interpret p1 as the proportion. So if we observe the value of x repeatedly, then think of p of p1 as the proportion of times the value of x is equal to x1, and p2 is the proportion of times the value of x is equal to x2, and so on. So then if you think about this sum, this is giving us the weighted average value of x, of the weighted average values, weighted average of the values of x. Here's an example. Let's say that x is the number of times a bottle cap drops with open side up in 3 tosses. The table, the distribution table for x is given here. So x could be 0. That means that the bottle cap drops with open side down all 3 times. 1 would mean that in 3 tosses the cap drops with open side up once, and then 3 means the cap drops with open side up 3 times in all 3 tosses. So these are the associated probabilities, let's say. So what is the mean? Well, the mean mu of x is the following. So we multiply each value of x with the associated probability. So 0 would be multiplied by 0.2027, plus 1 would be multiplied with 0.189, plus 2 would be multiplied with 0.441, plus 3 would be multiplied with 0.43. Let's see, I think this value, the last value is actually 0.343. Let me make sure that that's the case. 0.027 plus 0.189 plus 0.441. Yeah, so the last value here would be 0.343, which is what I have correct here. So, and then if we compute this, we get 2.1. So 2.1 is the average value here. So what it means is that if we repeatedly if we carry this experiment repeatedly, so tossing the cap 3 times, if you do it repeatedly, then in the long run, on average, we expect that the the open side will be up 2.1 times. The law of large numbers says that as the number of randomly drawn observations in a sample, so you're picking a sample from a population of size n. So as the number of randomly drawn observations n, or the sample size increases, the mean of the sample x bar gets closer and closer to the population mean mu. This is the law of large numbers. It's valid for any population. So all this is saying, let's say we are looking at some measurement or some attribute or variable x for a given population, and mu is the mean of that attribute or variable. And what this is saying is that we can look at the sample mean as a approximation for the population mean, and the sample mean approximates the population mean better and better as we increase the sample size. So here is a graphical representation of that. So the mean of the first n observations. So as the number of observations increases, the mean gets closer and closer to right here. Let's say 25 is the mean, so it gets closer and closer to the mean. The variance of a discrete random variable. So again, let's say this is the probability mass function, the table here, or the distribution of x. And let's say we have already computed the mean of x. Then so let's say that mu x is the mean of x. So then the variance is denoted by sigma x squared, and the variance is given by the following sum. So it is x1 minus mean of x squared times p1 plus x2 minus mean of x squared times p2 plus dot 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 xk minus mean of x squared times pk. And this is the summation notation for this sum. So then we are asking, basically what we're doing here is that from each value of x we are subtracting the mean, and then we are squaring it, and then we are multiplying it by the associated probability, and then at the end we are adding all these terms. Now the way we can look at it is that so you can think of it as the following. We can define this new variable, let's call that y, and y is the square of x minus mu. So imagine that y is equal to square of x minus mu. So that's basically the squared distance from x to its mean. And so then the mean of y is basically the variance here. So the variance is basically the mean of the squared distance from x to the mean of x. So again, the variance is the expected value or the mean value or average of the squared distance from x to its mean. The standard deviation of x is denoted by sigma, or sigma subscript x, and it is basically the square root of variance. The variance and the standard deviation measures the spread or variation of the variable. The variance is the weighted average of the squared deviations of the variable x from its mean. The larger the variance of x, the more scattered the values of x on average. Let x be the number of times a bottle cap drops with the open side up in 3 tosses. The table below provides the distribution of x. What's the variance here? So the variance of x here is given by the following. So from each value of x, I subtract the mean, and you can recall that the mean was 2.1. So we calculated the mean in the previous slide here. We got 2.1. So from 0, I subtract 2.1. I square that. So this is the squared deviation of 0 from the mean. And then we multiply by the associated probability, 0.027. Plus, and we do the same thing with all the other values. So from 1, subtract the mean, 2.1, square, multiply by the probability, 0.189, plus 2 minus 2.1 squared times 0.441, plus 3 minus 2.1 squared times 0.343. And if we simplify, we get 0.63. So that's the variance of this variable x. Now, if we want to find the standard deviation, we simply have to take the square root of 0.63. Couple of properties of the mean. So if we know the mean of x, then the mean of a plus b times x, where a and b are constants, the mean of a plus bx is the same as a plus b times the mean of x. And for any two random variables x and y, the mean of x plus y is the same as mean of x plus the mean of y. Some properties of the variance: if x is a random variable where and a and b are constant, then the variance of a plus bx is the same as b squared times the variance of x. If x and y are independent variables, then the variance of x plus y is equal to variance of x plus the variance of y. If x and y are not independent, and so they have a correlation, say given by rho, then the variance is given by the variance of x plus y is given by the variance of x plus the variance of y plus 2 times rho times the standard deviation of x times the standard deviation of y. Let's look at an example. Let's say that the weight of medium-sized tomatoes selected at random from a bin at the local supermarket is a random variable with mean 10 and the standard deviation 1 ounce. Suppose we pick 4 tomatoes from the bin at random and put them in a bag. Define the random variable y to be the weight of the bag. What is the mean of this random variable y? So what is the mean weight of a bag? Well, to understand this problem, what we have to do is the following. So we are picking we are putting 4 tomatoes in the bag, right? So think of W1. So think about you're putting tomatoes in a bag. So W1 is the weight of the first tomato. W2 is the weight of the second tomato you put in the bag. W3 is the weight of the third tomato. And the W4 is the weight of the fourth tomato you put in the bag. So then the weight of the bag would be the sum of these 4 weights. And what we want to find is we want to find the mean of this sum, right? So we want to find what is the what is the mean of this? So what is the mean of this sum? Well, because the mean weight of a tomato is 10 ounce, right? So that means the mean of each of this. So all we have, so mean of this sum would be the mean of W1 plus the mean of W2 plus the mean of W3 plus the mean of W4, and each mean here is 10, so the mean of the sum would be 40. So the answer is that the mean is 40 here. Okay, so again, going back to the tomato, the previous example, but now this time we're asking what's the standard deviation of the variable y. So once again, so recall that we are putting 4 tomatoes in the bag, and the weight of the bag is the sum of the weights of the 4 tomatoes. And W1 represents the weight of the first tomato, and WT is the weight of the second tomato, and so on. And we found that the mean weight is found by taking the sum of the means of the weights of the 4 tomatoes. So we got 40 there. Now, to find the standard deviation, we apply the formula. So here we're going to assume that we're going to assume that we have so many tomatoes that when we pick a sample of 4 tomatoes, the variable W, so W1 is the variable that represents the weight of the first tomato picked, WT represents the weight of the second tomato picked, and so on. And we're going to assume that these variables are independent. So in that case, the variance of this sum would be the sum of the variances. So here we just take the sum. So the variance of each tomato is 1. So since we have 4 in the bag, so the variance would be 4. The variance of the weight of the bag would be 4. And then for standard deviation, we have to take the square root of 4, which is 2. So we get the answer is C. Suppose that you invest 20% of your funds in treasury bills and 80% of your funds in an index fund that represents all US common stocks. Your rate of return over time is proportional to that of the T-bills and that of the index fund Y. So here X is the rate of return from the T-bills, and Y is the rate of return from the index fund. Then the rate of fund from your portfolio would be 0.2x plus 0.8y. And based on annual returns between 1950 and 2003, the annual return on T-bills is the average of that. The mean return from T-bills is 5%, and the standard deviation of return from T-bills is 2.9%. The annual return on stocks, so the mean return from stocks is 13.2%, and the standard deviation of return from stocks is 17.6%. So the correlation between X and Y is given by -1,1. So then I want to know what is the mean the mean return from the portfolio. That is what is the mean of R, and the mean of R would be 0.2 times the mean of X plus 0.8 times the mean of Y. And so mean of X is 5 and the mean of Y is 13.2. So at the end we get 11.56%. So the mean return from the portfolio is 11.56%. The variance of the return from the portfolio, that is the variance of capital R, is going to be the variance of, so it's going to be the variance of the first. So R has two terms here. So what's the variance of the first? Well, the variance of the first would be 0.2 squared times the variance of X squared, variance of X. So you get the variance of, okay, so the variance of R would be variance of 0.2x plus the variance of 0.8y plus 2 times rho times the variance of 0.2x times the variance of 0.8y. Now the variance of 0.2x would be 0.2 squared times the variance of x plus the variance of 0.8y would be 0.8 squared times the variance of y plus 2 rho and the 2 rho time. Okay, so what is the standard deviation of 0.2x? So that's going to be 0.2 times the standard deviation of x, and sigma 0.8y would be 0.8 times sigma y. And so at the end we just plug in, so 0.2 squared times variance of x is 2.9 squared, 0.8 squared, variance of y is 17.6 squared, plus 2 times negative 0.11, that is the correlation, times 0.2, so here's the 0.2 times the standard deviation of x, which would be 2.9, and 0.8 times the standard deviation of y, which is 17.6, and then we do all the simplification here, we get 196.786. So that's the variance, and then if I take the square root of that, I get the standard deviation, and the standard deviation turns out to be 14.03%. A commuter must pass through 5 traffic lights on her way to work, and she will have to stop at each one that is red. X is the number of red lights she stops at on her way to work. She estimates the distribution of X to be shown as below. On average, how many traffic lights does the commuter hit on her way to work? Well, here is the table, distribution table for X, and so we want to know the on average how many traffic lights does the commuter hit on her way. And well, so there are 5 traffic lights, and X is the number of red lights. So X could be 1, 2, 3, 4, or 5, let's say, and so X could be 0 as well, but let's say here we're assuming that the probability associated with 0 is 0. And so based on this table, what is the average or the mean of X, basically? And the mean of X is, well, you just multiply each value of X with the associated probability, and then you add them. So if you do that, you get 1 times 0.4 plus 2 times 0.25 plus 3 times 0.15 plus 4 times 0.15 plus 5 times 0.05. And then you see that you get 2.2. So on average, she is going to be hitting 2.2 red lights on her way to work. In the previous slide, we saw that the mean is 2.2. So let's also calculate the variance. The variance of X would be what? Well, from each value of X, we subtract From each value of x, we subtract the mean, and then we multiply by the associated probability. So the standard deviation, the variance will be given by the following. I should say variance. So 1.2.2 squared, 1 minus 2.2 squared times 0.4, 2 plus 2 minus 2.2 squared times 0.25, and so on. So for all these 5 values, we do that, and at the end we simplify, we get 1.25. I think the 1.25 is actually the standard deviation, not the variance. So at the end, once I calculate the variance, I have to take the square root of the variance to get to the standard deviation 1.25. Okay, so I'll stop the video here. In the next video, we'll be looking at some of the general probability rules. See you then.